aside from the basic mathematics of adding, subtracting, multiplying, dividing, I think solving equations and perhaps being able to interpret a graph are probably the two most important things that you could learn in mathematics. Solving equations is probably the number one thing at this level. Because if you can't solve an equation, you really can't move on in math. Also, if you can't graph, you really can't move on in math, because those two things are going to come back again and again and again and again. And so we want to get this down and get good at it. So I'm going to focus more on the mechanics of this chapter than the hey, here's a story scenario, although we'll do some of those too, but we're going to skip a fair bit of that as well. So solving equations. Equations are a balance. And I know you've done these before. It's kind of like a teeter-totter. If I have a teeter-totter, and I have the same amount of weight on one side as I do on the other, then it's in balance, right? It's like a scale. The balance point, this actually has a word, it's called the fulcrum, but the balance point, we don't need to learn that word, unless you're going to be a diver. Not too many divers in Idaho. The balance point is the equal. So when we see that something's equal, we know, or we should understand, that whatever's on one side has the same meaning, the same weight as what's on the other side. So let's say on this side I've got a couple of children. And on this side, maybe we've got their mother. And maybe the weights are in balance. They're equal. So when a teeter-totter is equal, that's actually when it's fun, because then you got to get it kind of going back and forth, right? It's when you have an unequal amount of weight that it kind of becomes a problem. So, like if mom is a lot heavier than her kids, then mom's going to go down and the kids are going to go up, and it's going to stay that way unless mom does some jumping or like steps off. And if she steps off, what happens to the kids? Yeah, they're going to go crashing down, right? So, balance point. Equations are a balance. And how we keep the balance is we use opposite operations. We use opposite operations to manipulate the equation while keeping the balance. Manipulate or change the equation. Is balance 1L or 2? I got a feeling it's 1. I think I spelled it wrong here. Bad spelling. So what are the opposite operations? What's the opposite of plus? Subtract, minus, yeah. What's the opposite of minus? Well, obviously that's plus, right? What's the opposite of multiply? You got it. And the opposite of divide? It's multiply, right. those are our four basic operations that we use a lot. Not just now, but for the rest of your math life. And the reality is we as humans do this sort of naturally. If you talk to somebody who maybe struggled in math and is out in the real world and they're, maybe they run their own business or something like that, or maybe they just work for somebody else and you say, what about that algebra thing? I never use that in real life. Yeah, you do. You do. I don't care who you are. You're always solving for some missing bit of information. That's sort of what math does. When we are learning math as young children, we're solving equations. When we do a problem like this, we're solving an equation. The only thing is where's the missing information? We don't tell you that because we don't want to confuse you with something as crazy as like an x. But where would x go here? Well, x is simply the answer, right? So when we solve a problem like this, hopefully at this point we can do that in our head. 4 plus 5 or 5 plus 4 is 9, right? So 9 equals the answer. X is simply the answer. Okay. Now, again, we didn't write that in 3rd grade or 2nd grade or whenever you started learning this stuff. We didn't write it that way. But the idea was there from the very beginning. There was a missing value. So when algebra starts moving the missing value around, sometimes we get a little freaked out. Now the biggest problem that I see, and I think I've mentioned this before in this class, is especially boys, smart boys, tend to get stuck in a pattern of, hey, I can do that in my head. Great, I'm glad you can. Show me on paper. And the reason for that is this. If I give you a problem like x plus 5 equals 9, yeah, I expect that you can do that in your head. Here's the thing that I don't want you to do, and here's the problem that I see some smart kids, again, especially boys, doing, is they look at that and they try to solve for x. And that's the mistake. You don't solve for x by looking at x. You solve for x by moving everything else. You get rid of everything else. And so sometimes we take these easy problems, which, I mean, I'm not trying to insult anybody's intelligence here. We know that's 4, right? Okay. But we need to make sure that we understand how to get to that 4. I have to use an opposite operation. And anything that I do to one side of an equation, I have to do to the other side of the equation. Why do I have to do that to keep it in balance? Well, if I have 2 pens in one hand and 2 pens in the other, I'm in balance. What if I drop a pen? What happens to the balance? Yeah, it's not in balance anymore. So what do I have to do to keep it in balance? Drop a pen on the other side. That keeps it in balance. My body is the equal sign. I'm the teeter-totter. What if somebody jumps on the teeter-totter on one side? Not in balance anymore. What do we have to do? We got to find a friend over here, right? That's the entire idea of solving an equation. Keeping the teeter-totter in balance. So whatever you do to one side, you have to do to the other. Now, I had a teacher years ago that did something like this. They didn't draw the triangle there, but there's my little balance thing. This is our teeter-totter. Okay. He put a couple of lines down the equal sign, and he taught me to always keep the equal between the lines, and that anything you do to one side, you do to the other. Now, I've seen teachers do it with just one line through the equals, but I think it's a good strategy, especially if you get things kind of mixed up. Now, to be honest, I don't use it much anymore, but I think it's a good practice. So it helps me remember that whatever I do to get rid of this 5, I've got to do the same over here. Right? Don't focus on what is x. focus on how can you move the numbers away from x, and you will be successful in this. Again, I'm not trying to insult anybody's intelligence with an easy problem that I expect that you would be able to do in your head, but it gets to the point where you can't do them in your head anymore. And that's where the problem lies for these smart kids that kind of go, well, I can do that in my head, I don't see the point in showing the work. Well, then they've never really learned how to do the work, and so you're stuck with this problem that you look at and you go, well, I don't know what that is, right? I don't think the whole combined brain power of the human race could figure that out, so I'm skipping it. When in fact, a lot of times it's fairly easy if you just take one step at a time. All right, let's see if I can pull up a couple of examples from your assignment here and look and see what we've got going on, because they're definitely going to give us problems that are harder than this. This is more along the lines of what we're going to be working on. And again, if we just simply look at x and go, what number would I plug in for x to make this true? I'm sure there are some people in here that can do that. But that's far more effort than it needs to be to solve this problem. So what I'm going to do is I'm going to look at this and I'm going to say, okay, what can I do with this? Now, there's a few different first steps you could take here that would be just fine. My first step would be, honestly, I'm going to get rid of the fraction, right? I want to get rid of that 3. What's the 3 doing to the x and everything else up there? It's dividing it. So what's the opposite of divide? Exactly. So I'm going to multiply both sides by 3. Now, what's going to happen is this. I don't really need to multiply the 3 here because these 3's will cancel. The whole point of doing the opposite operation is to cancel these 3's. 3 divided by 3 is 1, and 1 is not necessary here. So that gives me a 2 times x plus 4 equals 36. Get rid of the fraction. If you've got a fraction, that's usually the first thing I take off and get rid of. Not always, but usually. Now what? What can I do? Any first steps? Yeah, Ken?
You need to distribute the 2 to the x and the 4.
That's a way that it can be done, yes. Does anybody see another way to do it? Not that I think that's a bad step. I don't. Nathan? Yeah, I can't really subtract the 4 because it's in the parentheses. It's not really 4. It's actually 8 because it's 2 times 4. So you got to be careful about that. That is what most people would do. There is another way. Yeah?
Divide the 2.
Yeah, divide the 2. Now, is one way better than the other? No, not necessarily. But I like to keep math as simple as possible. If I distribute the 2, I run the risk of forgetting something. And the forgetting in distributing that most people make is they distribute the 2 times the x, but they forget to do it times the 4. So if you distribute the 2, it'll work beautifully if you don't make any mistakes. But we can also divide this by 2. Which way you choose to do it is entirely up to you, and I have no problem with it. I'm just saying that this way I think there's less chance of an error. Now, the reason I can do this is because this 2 is multiplying the parentheses. The 2 can't see into the parentheses. It just thinks, hey, there's a number in there, and it would be right. It doesn't know that there's like 2 terms in there. So I can, because of the parentheses, I can simply divide by 2 on both sides. And I get x plus 4 equals 36 divided by 2. That'd be 18. Okay. And then I just simply subtract 4. oftentimes at this point in the game, when I see, if I see a student get to here and then just say x equals 14, I'm usually pretty accepting of that. But I am not accepting of a student taking the whole thing and just going x equals 14. That will not get you any points in this class. So if you're taking a quiz or a test, I need to see the steps, because the whole point is to see the steps. It's not the answer. And if you make all the steps and you take all the steps correctly, but you make a simple math error, you're probably going to get all, if not most of the points available in that question. I want to see the process, the steps. So what if we distributed the two here? What would that have looked like? Because most of you said distribute the two. Let me go back to that part. If we distribute the two, that's going to give me 2x plus 8 equals 36. Again, nothing wrong with doing it that way, just don't forget to distribute to everything in the parentheses. And then we would subtract 8. Oops, 28, not 14. And we get 14. Alright. So let's look at a couple more problems. Let's pop your book open to page 4. It's handwritten on the top. So I just did that one in the notes. If you wrote it down in your notes, you don't have to do it again, but if you didn't, you should do it. So here we know that x equals 14. These are three problems that look pretty similar, but I don't think the answers are the same. So how might I start this problem? I'm going to say there's two possible steps here. We could either distribute, or, Kale, what else could we do? Yeah, we could divide. Does anybody, how many people like the distributing idea? A couple of you? Alright. Three? Dividing? Oh, wait a minute, Shelley, didn't you vote twice?
I like both.
Oh, okay, alright, fair enough.
Dividing's a little better, but
I think so. I think so. Alright, well then, since the majority of us said that we liked the dividing first, let's divide. So if we divide both sides by 2, this is going to cancel, and you can distribute, but the problem with distributing here is you're going to multiply 2 times x over 3. That seems kind of ugly to me. I mean, it can be done, it's not that big a deal, but if you don't like fractions, this is a better way to do this problem. Okay. So then that's going to leave me with, I'm going to have to kind of work it sideways, x over 3 plus 4 equals 12 divided by 2 would be 6. What might be my next step here?
times 3.
We could times 3. Nathan, there would be a potential problem if we did that first. What would we times 3 by? Would we times it here and here?
Next to the step.
Okay. So,
Subtract 4.
I think that's a better step, because if we do times by 3 here first to get rid of the fraction, we have to times this, this, and this. So I think a better step here would be to subtract 4 from both sides. I don't know, my hand isn't writing right. So that's going to cancel these. So then I'm going to have x divided by 3 equals 2. Now, what's the x? What is the 3 doing to the x? Not sure. Fractions are division problems. So the 3 is dividing the x. How do we undivide? What's the opposite? We would times both sides by 3, right? And that's going to cancel this. So we get x equals 6. Now these two problems looked similar, but they had very different answers. Let's do this guy here. Could I subtract the 4 first here? Anybody? No? Yeah, I don't really want to subtract the 4 here because what this really is not 4, it's 4/3 because the 3 is dividing it. It's not really 4. So that wouldn't be the first thing I'd want to do. I would want to get rid of that 3. So the 3 is dividing everything up front, up top. You can kind of see this as having parentheses if you wanted to. So how about if we multiply both sides by 3? Kind of like we did in the first one up here in our notes. So that's going to give us 2x plus 4 equals 36. Then what should we do next? Subtract 4. You got it. You got it. That's exactly what you do. So that would be 32. So the last thing we would do then is divide by 2, I think. So even though all 3 of these kind of look the same, all equal 12, all sort of had the same digits in them, they were arranged differently, and so they have different answers. Let's get one more before I... This is something we haven't taken notes yet, but these are... This is an algebra proof. They want us to do an algebra proof for this. So what they want us to do is say what happens to get from step to step. So we want to work the steps, but then we also want to make the statement of what happens. Let me tell you a quick story about proofing. When I went to school, I didn't do an algebra proof like we're going to do here real quick. I think you'll find that it's really simple, okay? But I didn't do proofs until I got into geometry. And I was doing really well in geometry. This was in college. And we got to geometric proofs, which are a little harder than what we're going to do here, but it's the same idea. And so like the first day the teacher teaches us how to do proofs, and I go home and I do the homework, and I come back the next day and he puts his proof up on the board, and I look at my proof and I look at his proof, and they didn't match. I'm like, dang it, I guess I must not be getting this. So then the next day comes along, he puts up his proofs and I look at my proofs, and I think I matched one, and there were like 3 or 4 that I didn't match, and I'm like, dang. And this was a class I'm starting to feel good about because I hadn't really felt good about math for a long time. So I'm getting kind of down on myself, like, yeah, maybe I'm not really smart, maybe this college thing isn't for me. So by the 3rd day, he puts his proofs up, I look at my proofs, they're not matching. I think I maybe matched one. And I was almost in tears. I'm like, okay, well, Yeah. You know what I mean? Talking about judging yourself. If I'm judging myself to be stupid and I just can't do it. So I go to Professor Larson's office when he had office hours. And I said, hey, Professor Larson, I'm in your geometry class and I've really felt good about math for the first time in a long time. I've really been getting geometry, but these proofs, I don't understand them. And he says, well, let me see what you got. So I get them out and I show him, and he's like, yeah, I said, well, these are fine. I'm like, yeah, but they didn't match yours. He said, they don't have to match mine to be correct. As long as we get to the same answer and you take your steps, the steps that you took were correct. Kind of like this problem here, right? You guys, some of you said distribute here. Well, I divided. But whichever way we went, didn't we come up with the same answer? And that was the point he was made. And for me, that was like, boom, whoa, wait a minute. You mean my work doesn't have to match the teacher's for it to be right? No, not at all. You just have to take the steps correctly. And so learning what those steps are, that's the critical part. And that changed my whole perspective on math and learning in general. All right, so let's look at this. We have some properties. The addition property of equality, the subtraction property, division, multiplication, distributive, and substitution. We probably won't use substitution all that often. So let's look at this problem here. They've taken this problem and they've turned it from this to this. What did they do to get from here to here? Yeah, Damon.
They added the x on the right side to the left side.
I would agree. So they added x. Right? Now, what we want to say is what property allowed us to do that? What of these properties do you think we just used there? Yeah. You would be absolutely correct. The addition property says you can add anything you want on both sides of an equation. As long as you're doing it to both sides, you can do anything you want, add anything you want. So this is the addition property. Good. Okay? We use the addition property to get to this point. Now, what was used to get from here to here? What did they do? Damon again?
Subtract 2.
I subtracted 2. That's right. And that's going to get us to here, right? So what property was that? The subtraction property. And then, what do we have to do to get from here to here? Damon again? Divide by 4. Right. And so what property is that? Division property. Yeah. Oh, is that? The division property. So you're going to be asked a few times, I don't know how much today, but you're going to be asked a few times to do a proof, and this is how you do it. All you have to do is say what it is that allows you to go from step to step. Now, I believe there is a test question like this on the next test, so just so you know. It's not hard. It's quite easy. We just have to be able to follow what's happening. All right, so I'm going to let you guys go, I think, here on the ready, set, go. There are a lot of problems here. Let's do this. Let's, for now, oh, by the way, backing up here. On this thing, this guy right here, where we started, was called the given. So we use the addition property to get here, and the subtraction property to get to the next step. You always have to be given something. I want you to do 4-1, so page 7, page 8, page 9, and let's leave page 10. Let's leave page 10 alone for now. So 7, 8, and 9 today. Okay? Give those a try. I'll come around and help out once I get roll taken.